This is problem number 3 from the first practice final. So we're told that the collector current is 3 milliamps, beta is 100, and we're asked to calculate the saturation current, and we're told that VEB is not equal to 0.7 volts, so we don't know what VEB is. So we have these, which are all our BJT identities, and so we can see that we can use this equation in order to find the saturation current. So if we rearrange the equation to find the saturation current, we get the equation that looks like this. And instead of using VBE, we're going to use VEB, because we can see by the way that the arrow is pointing that this is a PNP transistor, so the current flows from the emitter to the base. So we are given IC, we know what VT is, it's 25 millivolts, but we don't have VEB, which we need to find the saturation current. So first we need to find what VEB is. We know that VEB is equal to VE minus VB. And we have a voltage source right here, and the voltage here is the same as the voltage right here at VE. So this means that VE is equal to 1.5 volts. So now we need to find what VB is. VB is right here, so we can use Kirchhoff's laws to try to determine it. So from Kirchhoff's laws, we know that IB is going to be equal to VB minus 0 divided by 23 kiloohms, but we don't know what IB is. However, we have this BJT identity, and since we know what IC is, we can use this and rearrange it to find what IB is. So IB is going to be equal to the collector current divided by beta, so it's going to be 3 times 10 to the negative 3 divided by 100, and we're going to get that IB is equal to 0.03 milliamps. And so then we can plug this into this equation. We're going to get that 0.03 times 10 to the negative 3 is equal to VB divided by 23 times 10 to the 3. And then we can multiply both sides by 23k to cancel this out. And we're going to get that 0.69 is equal to VB. So VB is equal to 0.69 volts. And so now that we know what VB is, we can plug that into this equation. So VEB is equal to VE, which we said was 1.5 volts, minus 0.69, which is what we just found to be VB. And that's going to be equal to 0.81 volts. So now that we know what VEB is, we can plug that into this equation. And so IS is going to be equal to the collector current, which is 3 times 10 to the negative 3, divided by E to the VEB, which we found to be 0.81, divided by VT, which is 0.025. And so we're going to get that IS is equal to 2.55 times 10 to the negative 17 amps.